This concept bite will provide you with everything you need to remember from your last lesson on the periodic table. Firstly, it is important that you remember what the mass number and the atomic number of an atom describe. The mass number of an atom describes the number of protons and neutrons in the nucleus of an atom. The atomic number of an atom describes the number of protons in the nucleus of an atom. For any particular atom, this information can be shown as simply as this. The modern periodic table is one of the most important tools that a chemist has. We are now going to discuss some of its important features that you will need to remember. The vertical columns on the periodic table are called groups, and the horizontal rows are called periods. Group 1, the alkali metals, Group 7, the halogens, and Group 0, the noble gases, are three important groups in the periodic table that you will learn a lot more about over the next few lessons. The transition metals are placed in the centre of the periodic table between groups 2 and 3. So how are the elements in the periodic table ordered? The elements in the periodic table are arranged in order of increasing atomic number, as shown in this diagram. The inner transition elements are usually dropped out of their proper places and written at the bottom of the periodic table. This diagram shows the inner transition elements in their proper place. The simple reason why the metals are separated is to make the periodic table smaller and easier to read. It is a well-known fact that elements in the same group have similar chemical properties, but why is this? Apart from helium, elements in the same group have the same number of electrons in their outer energy levels. These outer shell electrons govern how the element reacts and determines its chemical properties. The number of electrons in the outer shell is the same as the group number for groups 1 to 7. Finally, we're going to look at the position of metals and non-metals in the periodic table. There is a division between metals and non-metals in the periodic table as shown here. Although the division looks clear-cut, in practice there is a lot of uncertainty on the dividing line. For example, arsenic has properties of both metals and non-metals.